Hello guys, I'm Kumar. In this video, we are going to say about CPU scheduling. In this CPU scheduling, we have three algorithms: first come, first serve, shortest job first, next is round robin. So now we're going to say about first come, first serve. In this first come, first serve, I'm going to declare a first function as waiting time of processes, n, burst time, waiting time. Waiting time as a WT of 0, WT of 0 equal to 0. Then for loop, I am using for loop here. For I in range of 1 comma n, then WT of I equal to burst time of I comma minus 1 plus WT of I minus 1. Next we are using a function as turnaround time of turnaround time process comma n comma burst time comma um, waiting time comma turnaround time. Next using for loop for turnaround time. So for I in range of n, tat of I minus tat of I equal to bt of I plus wt of I. Next we're going to declare next using a function like find average time. So find average time of process comma n comma bus time. So wt equal to 0 into n, then tat equal to 0 into n, then total waiting time equal to 0, then total turnaround time equal to 0. Next waiting time of process comma n comma bt comma wt, then turnaround time of process comma n comma bus time comma waiting time comma turnaround time. Next I'm printing a process bus time and waiting time and the turnaround time. Next I'm using for loop for again range of n, then total waiting time equal to total waiting time plus waiting time of 5. Next total turnaround time equal to total turnaround time plus total turnaround time of 5. Next using a str of 5 plus 1 for next is str of bus time of I, then str of waiting time for I, waiting time of I. Next str of turnaround time of I. Next we're getting a average waiting time. So instead of total waiting time by n, next we're getting average turnaround time. So instead of total turnaround time by n. Next we're going to get a number of process. So getting input like n equal to int of input of enter number of process. So process of and burst of. Then using for loop here for I in range of 0 comma n, then procedure dot append of I in I plus 1. Next we're going to get a bus time for next we're going to get an input for a bus time. So enter bus time for process. Next next the number will append by 1 by 1. Next finding average time for process and n and bus time. So now in another program, the program is running. So now it's asking for enter the number of process. I'm going to give number of processes 4. So it's asking enter bus time for process 1. I'm going to give bus time as 7. Now it's asking enter bus time for process 2. I'm going to give bus time as 4. Next is asking enter the bus time for process 3. I'm going to give bus time as 2. Next is asking enter the bus time for process 4. I'm going to give bus time as 5. So the first FCFS first come first serve algorithm is here. Output is here. So the process 1 is 7. The process 2 is 4. Process 3 is 2. The process 4 is 5. Then waiting time is initially it will be 0. Then it will next it 7 and 11, then 13. Then turnaround time is 7, 11, 13, 18. Then average waiting time, it will be the adding all the adding all the wait time by 4. So the average waiting time is 7.75. Then adding all turnaround time by 4, it will be the 12.25. So next we are going to see about the shortest job first. So first we're getting an input like a entire number of process. So n equal to int of input of entire number of process. So next getting an input for a dict. So d equal to dict. So next using for loop for I in range of n, then key equal to p plus str of I plus 1. Next getting input for the best time of process. Next next using declaring L, then L append by append of a, then dictionary of key equal to L. Next we sorting the d. So d equal to sorted of the d dot items, then k equal to lambda, then item of 1 comma 0. Then we using et. Et is a exit time. So so et next using a for loop for et exit time. So for I in range of ln of d, if I equal to 0, then exit time dot append of d of I 1 and 0. Else it will append et of I minus 1 plus d of I 1 0. Next turnaround time, using for loop for turnaround time. So for I in range of L of d, length of d, so turnaround time dot append of exit time of I. Then average turnaround time equal to 0. Next waiting time, using 18 time for loop for waiting time for I in range length range of length of d, then waiting time dot append of turnaround time of I minus d of I 1 0. Then average waiting time equal to 0. Then using for loop for I in tat turnaround time, then average turnaround time incrementing the I plus equal to I, then average turnaround time equal to average turnaround time by n. Next using for loop for I in waiting time, then average waiting time incrementing. So average waiting time plus I equal to I, then average waiting time equal to average waiting time by n. Next printing a process burst time, exit time, then turnaround time, then waiting time, then getting a turnaround time as output and average time as output. So in another program, so how does to job first. So now it's asking for the enter the number of process. I'm going to give number of processes 4. Now it's asking burst time for process 1. I'm going to give a 6. Next burst time for the process 2 is I'm going to give a process time burst time as 8. Next is asking a burst time for process 3. I'm going to give a 7. Next is asking a burst time for the process 4. I'm going to give a 3. Next the output will be printed. So the process 4 so process 1 is the 6. So process 4 and process 3 process 1, process 3, process 2, then burst time is a 3, 6, 7, then 8, then exit time is a 3, 9 and 16, 24, then turnaround time is a 3, 9, 16, 24, then waiting time is a 0, 3 and 9 and 16. The turnaround time 3, 9, 16 and 24 will be calculated by 4. Then the output will printed as a 39.0. Turnaround time will be added by 3 plus 9 plus 16 plus 24, then it will be divided by 4. So the output will be printed as a 13.0. Next waiting average, we have to calculating average waiting time. So 0 plus 3 plus 9 plus 16 divided by 4. So the output will be the 7.0. Next we are going to see about the round robin. So def find waiting time of process comma n comma burst time comma waiting time comma quantum. So remember burst time equal to 0 into n, using for loop for the for this burst time. So for I in range of n, then rem bus time of I equal to bus time of I, then t equal to 0, then using while loop here, while of 1 will while of 1 is a 1, done equal to true. If it's a true, it will using for this, it will go for this for loop for I in range of n. If rem of rem best time of I is greater than 0, then done false. The best time of I is greater than quantum, it will go for incrementing. So t of t plus equal to quantum, then rim best time of I minus equal to quantum, else it will go for t equal to t plus rim best time of I. Then we'll again go for a waiting time of I equal to time t minus bus time of I, then run bus time of I equal to 0. If done equal to true, then it will break. Then we declaring a function find a turnaround time of process n comma processes comma n comma bus time comma waiting time comma turnaround time, and then using for loop for this finding turnaround time for again range of n, the turnaround time of I equal to bus time of I plus waiting time of I, then using a function declaring a function finding a average time of a processes comma n comma bus time comma quantum, then waiting time equal to 0 into n, then turnaround time equal to 0 into n, then finding a waiting time of process comma n comma bus time comma waiting time comma quantum, then finding a turnaround time of process comma n comma bus time comma waiting time comma total turnaround time. Next, printing a bus time process bus time and waiting time and turnaround time. Then declaring a total waiting time as 0 and total turnaround time as 0. Using for loop for this, and for I in range of n, total wait time waiting time equal to total waiting time plus waiting time of I. Then total turnaround time equal to total turnaround time plus turnaround time of I. Then printing a I plus 1, and then bus time of I, then waiting time of I, then turnaround time of I. Then getting a output for this average waiting time, then average turnaround time. So in average waiting time, we are calculating we'll get output as a float. So using percentage dot 5f, and here also we're using a percentage dot 5f. So it will be total waiting the output will be total waiting time by n, then average turnaround time output will be the total turnaround time by n. Next, declaring a process. So we are using a 3 process, and so n equal to 3. Then bus time is 24, 3 and 3. Then quantum is 4. Then finding average time as a process and n plus time and quantum. So now we run the program. So the process 1 and process 2, process 3, bus time is 24 and 3 and 3. Waiting time is 6, 4, 7. Turnaround time is 37, 10. So the average waiting time is 6 plus 4 plus 7 by 3. So the output will be 5.667. Next, turnaround time. Average turnaround time output will be 30 plus 7 plus 10. 47 by 3. This will be output as 15.667. That's all, guys. This is the 3 algorithm we see in the CPU scheduling: round robin and shortest job first. Next, first come first serve. These are the CPU scheduling. That's all, guys. Thanks for watching.